Hi, welcome to my YouTube channel. This is Harimon Varshney. In this tutorial, we are going to see a thermal expansion and contraction due to temperature difference. So, in this case, oh, we are going to work a on a part that is going to be in a cryogenic temperature at 100 Kelvin. So, let's start. First, we are going to put engineering data, then geometry, and in the end static structure. We are going to share engineering data here and geometry. So double click on engineering data and go to engineering data sources, and we have already added one. I have created this customized library here and added this aluminum alloy. So this material we are going to use at low temperature. So we are going to close this one, then new space claim geometry. So now this space claim has been opened. Now we have to create a geometry. So we are going to create a cylindrical bar. So press V and then create this one, dimensioning 15 mm. And we are going to press this parameterize, so we can change the dimension in analysis for different length. Okay, so if you go to groups, so you can see here this dimension has been added. Okay, close this space claim. Now you can see this parameter set has been added here. Double click on model. So this has been opened here. Now click on geometry. Here we are going to change the material of this geometry from structural steel to aluminum alloy. Okay, so aluminum alloy, this is having property of all the coefficient of thermal expansion, yield, ultimate strength, Poisson's ratio, Young modulus. So now we are going to generate mass. Okay, if now we have to click on static structure. Here we can see environment temperature. So here we are going to set 20°, and in this we are going to enter frictionless support. Here we are going to apply. Okay, now insert thermal condition. So cryogenic temperature will be 100 Kelvin, and that will be minus 193 degrees centigrade. And geometry, we have to select this hole, apply. Now solve. Okay, now we are going to insert deformation directional. So we want thermal contraction in this direction. So that is Z direction. Okay, now evaluate all results. So we can see So that deformation is minus 0.2556. So that is like dimension is reducing by this and we want to confirm this by a hand calculation. So this is Excel sheet I have created calculation. Thermal expansion coefficient is there, length is 50 mm, room temperature 20 and working temperature minus 193 degrees centigrade. So if we see increase in length, delta L will be a alpha L T2 minus T1. So this is coming minus 0.2556 and that is matching with this analysis. Now we want to create a parametric results also we want. So I have created 50, 60 and 75, that is the length. So this calculation has been obtained using data table. That is using this what if analysis data table. So we are going to create parametric output in that workbench. So double click on parameter set. So before going here, what we have to do, what output we want this minimum. So we have to click here also to make this result parameterize. Okay. Now you can see directional deformation minimum, that is also output parameter, and this is input parameter, that is length. So what we are going to change this here, 55, 60, 65 and 70. We want the result here how much deformation will be there. So now we want update all design points. So now we are updating this. So now you can see these results have been updated and we are going to compare this with this Excel sheet. So here you can see minus 2556, 28116 and 30672, 33228, 35784. So all these results are matching with the results obtained in this analysis. So thank you for watching. Please like and subscribe my YouTube channel.